Hi Flashes, this is Mrs. Reed. Today I'm going to be going over your exponents, scientific notation, and squares and square roots study guide. So the first part here is we are going to simplify the expression, write your answer using only positive exponents. So remember, with this first one, when we are multiplying, you are going to keep your bases the same in your answer. So notice how our bases are V's here. So we're going to keep V in our answer. And then remember, all that we have to do when we are multiplying is we just add our exponents. So if we were to take 3 plus 6, that is going to give us 9. So our answer is V to the 9th. Number 2, again, notice how the 6's here are bases. The 6's are not coefficients because there's no variable next to them. So again, you're going to keep your base the same. And then this time, since we're dividing, the rule is you subtract your exponents. So 8 minus 2 gives us 6. So your answer is 6 to the 6th power. All right, number 3. So now notice how we do have coefficients since we do have numbers that are shoved up next to variables. So if you do have exponents, you're just going to do the operation like normal. So here I'm just going to take 4 times 5, which gives me 20. And then you can work with your bases. So again, we have bases of u's. So you're going to keep your base in your answer. And then the rule is you're going to add your exponents when we're multiplying. So 3 plus 12 gives us 15. Number 4, so remember the rule is anything to the 0 power just equals 1. So I can technically cross this out because this is just the same thing as 1 times b to the 15th. And 1 times anything is just that anything. So our simplified expression is just going to be b to the 15th power. Number 5, so now that we have something raised to a power, remember the rule is that we are multiplying. So when you're multiplying, you are using the distributive property to move this 5, to multiply the 5 with every single exponent on the inside of that parentheses. Please remember though that this coefficient does not have an exponent, but remember that there's that imaginary 1 there. So when you take this 5 to the 3, you also have to take the 5 to the 1 as well, because that 5 on the outside has to go to every single term on the inside. So your rule is you're multiplying the exponents. So this is 5 to the 1 times 5. So 1 times 5 is 5. So this will become 5 to the 5th power. Then you have c to the 3rd to the 5th power. So again, just multiply your exponents. 3 times 5 is 15. And remember guys, if you have an exponent that's 5 or less, we do want you to plug it in your calculator to simplify. So if I were to take 5 to the 5th power, I get 3,125. So my simplified expression is going to be 3,125 c to the 15th power. All right, number 6. So again, see if you can simplify anything here. So I see that I only have a 12 in the numerator, so I can't simplify coefficients. I only have an n in the denominator and a p, or n in the numerator and a p in the denominator, so I can't simplify anything. However, they do tell us that we only want to use positive exponents in our answer, so I do see that I have a negative exponent. So the way that I taught it in class is if the exponent is not happy downstairs, you then move it upstairs and it will become happy. So you're pretty much just taking the reciprocal. So you are already happy, so you're just going to leave them the same. And then as soon as you bring up that p to the negative 2nd, it will be with the 12 and the n squared, and then it becomes happy. So your simplified expression is just 12n squared p to the 2nd. All right, number 7. So as soon as I see parentheses shoved up next to each other, that means that we are multiplying. So I do know that I am going to combine my A's together and I'm going to combine my B's together. So remember, when we're multiplying, the rule is that you add your exponents. So a lot of students are going to see the a to the 8th power and a to the nothing power. So then they're going to say that a to the 8th times a is just a to the 8th power, which is not correct. Because remember, if there's no exponent with a variable, I want you to go ahead and add the exponent of 1, so that then when you're combining your exponents together, you can remember, oh yeah, I have to add 8 plus 1, which is going to give me 9. So when I simplify my a's, I now have a to the 9th power. Because again, add your exponents, 8 plus 1 gives you 9. Then when you go to combine your b's, we have b to the 2nd and b to the 0 power. Remember, anything to the 0 power is just 1, so technically the b to the 0 just cancels. So we only have one b to the 2nd power left, so we are just going to attach that with the a to the 9th. So this is your simplified expression. All right, and then the last one, number 8. Again, see if you can simplify anything on the inside first. We cannot simplify the r to the 7th over u to the 6th because we don't have same bases. So all that we have to do is take this to the power of 2. Remember, when you're taking it to the power of 2, you have to multiply the 2 to every single exponent, to every single term on the inside of the parentheses. And the rule is, when you're taking a power to a power, you are multiplying the numbers. So 7 times 2 gives me 14, so this will become r to the 14th power. Denominator, 6 times 2 is 12, so this will become u to the 12th power, and that is your simplified expression. All right, moving on to the word problem. So number 9, in 2013, the Los Angeles Dodgers opening day payroll was about 2.16 times 10 to the 8th, and the Houston Astros opening day payroll was about 2.4 times 10 to the 7th. How much higher was the Dodgers payroll? So first thing we need to do is figure out what operation we're doing. So since we're trying to figure out how much higher the Dodgers payroll is compared to the Houston Astros, that means that we are subtracting. So I'm going to take the Los Angeles Dodgers scientific notation of 2.16 times 10 to the 8th minus the Houston Astros payroll, which was 2.4 times 10 to the 7th. So remember, with scientific notation, when you're adding or subtracting in scientific notation, you have to have same base to the same power. So it's kind of similar to fractions when you're adding and subtracting. You always had to get a common denominator. So with subtracting and adding with scientific notation, you have to get same base to the same power first. And the way that I taught it in class, which is the easiest way to do this, is to always take your smaller exponent and change it to its larger exponent. So I am going to change this 10 to the 7th power into 10 to the 8th power. Now remember, as soon as you change your exponent, you need to say to yourself, okay, 7 plus what gave me 8? Well, 7 plus 1 gave me 8. So this plus 1 tells me how many times I'm moving my decimal point in my constant, because I need to get 2.4 times 10 to the 7th to equal whatever this constant is times 10 to the 8th. I'm trying to make sure that I still get the same standard form number when I'm adding 1 to my exponent. So plus 1 tells me I'm going to move my exponent one time. I just need to know if I'm moving it to the left or if I'm moving it to the right. So the easiest way to think about this is I added 1 to my exponent, which means I'm making my number bigger. So I need to account for that by making my constant smaller. So since I'm making my constant smaller, I need to move it back to the left one to make it smaller. So this constant now becomes 0.24 times 10 to the 8th. Okay, and again, both of these numbers are the same, so I know I did it correctly. Then your first scientific notation is going to stay the same, and now that we have same base to the same power, we can now subtract like normal. So if I were to take 2.16 minus my 0.24, I get 1.92. And then the reason why we had to get same base to the same power is because you're just going to keep that in your answer. So our answer here is 1.92 times 10 to the 8th. All right, number 10, a TV show had 3.5 times 10 to the 6 viewers for the first episode and 8.5 times 10 to the 6 viewers for their second episode. How many viewers did they have overall? So again, the first thing we need to do is figure out what operation we're doing. So since we're trying to figure out how many viewers they had overall, that means that we are adding. So I'm going to add my 3.5 times 10 to the 6 plus my 8.5 times 10 to the 6. Okay. Again, when we are adding and subtracting in scientific notation, I need to have same base to the same power. And notice how I already have same base to the same power, so I don't have to move anything, and I can just add like normal. So add your constants like normal. If you were to take 3.5 plus 8.5, that gives you 12. And then you keep your same base to the same power. Now, a lot of students are going to stop here and they're going to say that this is their answer. However, as soon as you see your constant, remember your constant has to be a number between 1 and 10. So if your constant is not a number between 1 and 10, this is not in scientific notation form. So what you're going to have to do is you're going to have to remember where the decimal point is at, which in any whole number it's at the very end. You then are going to have to move your decimal point until you get a number between 1 and 10. So if I move it to the back one, I now get 1.2. And as soon as you do that, you then have to change your exponent. So since I went back one, that means that I made this number smaller. So I need to account for that by making my exponent bigger. So since I moved it back one, I'm going to add 1 to 6, and this now turns into 10 to the 7th power. So this is my answer. All right, moving on. Number 11, how many times larger is 13,500 compared to 1.5 times 10 to the 3rd? Write your answer in standard form. So as soon as you guys see that I have a number in standard form and I have a number in scientific notation, I need to get both of these numbers to be both in standard form, or I need them to get into scientific notation form. So since they want my answer in standard form, I am going to make sure that both of these numbers are in standard form before I do anything else. So this 13,500 is already in standard form. However, this 1.5 times 10 to the 3rd is not, so let's go ahead and change that to standard form. Okay, so remember to change this to standard form. So remember to change this into standard form. All that we need to do is figure out our exponent here. So our exponent of 3 tells us how many times we're going to move our decimal point. And then since it's a positive 3, that means that we're making the number bigger. So since I'm making the number bigger, I am going to move it to the right. And again, I'm going to move it to the right 3 times. So 1.5, move that decimal to the right 3 times. Fill in your zeros where needed. So this now becomes 1,500. So I now have 13,500 and 1,500, and I'm trying to figure out how many times greater is this number compared to that number. So the operation that we're doing here is division. So if I were to take 13,500 divided by 1,500, I get an answer of 9. So it's 9 times bigger. Alright guys, and then the last one, an airplane traveled 5.7 times 10 to the 2nd miles per hour for 1.4 times 10 to the 1st hours. How far did the airplane travel? Write your answer in scientific notation form. Okay, so if they're saying that they traveled this many miles for this many hours, we are going to be multiplying these numbers together. Okay, since we're trying to figure out how far did it travel with this many hours, since we're trying to figure out how far did the airplane travel with this many hours, we are going to multiply these numbers together. So again, guys, when you are multiplying or dividing with scientific notation, you do not have to have same base to the same power, okay? If you get same base to the same power, then we're going to get different answers here, okay? The reason why we don't get same base to the same power is because we have rules that tell us what to do with our exponents when we're multiplying or dividing the numbers, and that's what we did at the top, right? So when we were multiplying, we added the exponents. When we were dividing, we subtracted the exponents. So that's why we don't have to have same base to the same power, okay? So all that we have to do here for number 12 is multiply your constants like normal. So if we were to take 5.7 times 1.4, we get 7.98. And then again, for your bases, you keep your same base of 10, and then since we're multiplying, you're just going to add your exponents. So 2 plus 1 gives us 3. So the plane traveled 7.98 times 10 to the third miles. Okay, so we are going to go ahead and move on to the second page. As you guys know, you guys can pause this video at any moment if you need to catch up on something. All right, number 13, select all the expressions that are equivalent to x to the third times x to the negative fifth. So guys, whenever it says select all, that means 9 times out of 10, there's probably more than one answer that's correct, okay? So the first thing that we are going to do is we are going to simplify this x to the third times x to the negative fifth to see what kind of answer we get, okay? So remember, when you're multiplying, you're just going to keep your same base. So we're going to keep x as our base. And then since we're multiplying, that means that we are going to add our exponent. So if we were to take 3 plus negative 5, that gives us negative 2. So looking at my answer choices down here, A was x to the negative second, which is what we simplify that to. So I know for sure that A is going to be one of my answers. B, x to the eighth, is not the same as x to the negative second, so B is not one of the answers. C is going to be one of my other answers, because remember, if your exponent is not happy, right now technically he's upstairs because I can put him over 1. So to make him happy, I just take the reciprocal. So the reciprocal of x over negative 2 over 1 is 1 over x to the second power, because as soon as you bring him downstairs, he then becomes happy. So that is the same thing as C. And then D is not one of the answers, because x to the negative second is not the same as x to the positive second power, okay? So our answers there should just be A and C. All right, number 14, fill in a number to make the statement true. So we have z to the fourth times z to the x equals z to the 10th. So what they want us to do here is fill in what number will make this statement true for x. Remember, when you're multiplying with bases with exponents, you are adding your exponents. So I need to figure out 4 plus what gives me 10. Well, 4 plus 6 gives me 10. So I know that x is going to be equal to 6. All right, number 15, plot the following numbers on the number line. So I am going to label these as A, B, C, and D to make it a little bit easier when I'm plotting them. So the square root of 20, again, you guys do have your calculator to double check. So if I were to figure out what the square root of 20 is, it's about 4.4, 4.5-ish, okay? But another way to think about it is I'm trying to figure out, where does the square root of 20 fall in between? So if I were to change my integers into their perfect square roots, I'm just taking 1 times 1 to get 1, 2 times 2 to get 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, and so on. I can tell that the square root of 20 is going to be in between the square root of 16 and the square root of 25. And then I can also say, okay, well, the square root of 20 is a little bit closer to the square root of 16 than the square root of 25. So I know it's going to be around the 4.5 area, but it probably is about 4.4 since it is closer to the square root of 16, which, as you guys saw on my calculator, that's what we got. Okay, so there's a couple different ways to plot non-perfect square roots, but try to see if you guys can do it this way first, and then use your calculator to double check that you did it correctly. So B, the symbol is pi, so we approximate pi as 3.14. So if I were to plot that on the number line, pi would be about right here. C is 2.349872 repeating, or goes on forever. So I'm just going to look right here at my whole number and my tenths place, which is about 2.3. So I'm going to go over to 2, and then 0.3 means I'm just going to go over a little bit more. So that means C is right there. And then the last one, D, square root of 5. Again, you can use your number line down here, the perfect square root. So I know that the square root of 5 is going to be in between the square root of 4 and the square root of 9. It will be closer to 2 than it is 9. So I know that it's going to be about 2.2-ish is what I'm going to guess. But the negative sign out front means that it is going to be negative. So this is going to be about negative 2.2. So I'm going to use my calculator to double check though. And that is about what I got. So negative 2.23. So that will be right here. All right, number 16. Which of the following is closest to point F on the number line below? So let's look. So here we have the square root of 7. If I were to figure out what the square root of 7 is in my calculator, it's about 2.6. So 2.6 is going to be about where E is. So I'm going to keep that as an option for now, just in case none of the other ones are closer to F. So let's look at the next one. So the next one, B, is 1 5/7. So you guys should know right away that B is not going to be an answer since E was about 2.6. This is going to be 1 point something, so we know that if F is about 3.5, we know that A is already closer than B, so we know that B is not going to be one of the answers. C, if I were to approximate the square root of 15, I get about 3.87, so this 3.87 is actually closer than 2.6, so I can now eliminate A as one of my answers. So let's see where D is at. So D, they try to trick you here with 35%. So a lot of students are going to be like, oh, 35% is in between 3 and 4, which is not correct because you need to change this percent into its decimal form to be able to see where it's going to be located at on the number line. So a couple different ways to do this. We know that percents are always out of 100. So if I were to take 35 divided by 100, I get 0.35. Okay, so that would be our decimal from this percent. Or the other way to do it is to move the decimal point 2 times to the left, and that will also tell you what your answer is. So 0.35 is about right here, which is not close to F. So we know that that's not going to be an answer. So we know for sure that C is the closest one to F. All right, number 17, estimate the value of 3 times square root of 10 to the nearest integer. So all that we're doing here is you can plug this in your calculator like this, or you can first take the square root of 10, and then this 3 out front just means that you're multiplying. So I'm just going to put it in my calculator as they showed it to me. So 3 to the 10th, or 3 to the square root of 10 is about 9.48. So about 9.5, but they do want us to round it to the nearest integer. So I'm looking at the tenths place. Is this number 5 or greater? Nope. So I'm going to leave the 9 the same. So 3 to the square root of 10 is the closest to the integer of 9. Number 18, fill in the blank. So again, I'm just going to type these numbers in my calculator. The number out front just means that I'm multiplying that number to the square root. But for my calculator, I can just type it in as so. So 2 to the square root of 15 is about 7.7. And then 3 to the square root of 6 is about 7.3. So 7.7 is greater than 7.3, so I know my answer is going to be A. All right, number 19. How many square roots does 49 have, and explain? So 49, the square root of 49. Remember, we talked about in class how when you take the square root of 49, you don't just get a positive 7. Okay, we also talked about how if you take negative 7 times negative 7, that also gives you that positive 49. So we talked about this plus minus sign. So what you guys have to say here, and when you're trying to figure out how many square roots does 49 have, you need to tell me that there's two answers, because the plus 7, the 7 times 7 is 49, but also the negative 7 times negative 7 is 49. So you guys just need to explain that in words. So I'm going to say 49 has 2 square roots, and then you just need to explain why. So I'm going to put because 7 times 7 equals 49, so positive 7 times positive 7 equals 49, and negative 7 times negative 7 equals 49. And then you can just leave it as that. Okay, so I said that it has 2 square roots, and it's because 7 times 7 is 49, and negative 7 times negative 7 is 49. All right, moving on to the last page. So between which two whole numbers is the square root of 40 located on the number line? So again, you can use your perfect square root here by filling in these numbers. So the perfect square root of 6 is 36. Then I get 49, 64, 81, 100, and so on. Or you can just use your calculator. So I know that the square root of 40 falls in between the square root of 36 and the square root of 49, which is in between 6 and 7. So let's just double check that. So the square root of 40 is 6.3, so I know that that is in between my whole number of 6 and 7. So I know for sure that it's A. Number 21, select all the following solutions to the equation, round to the nearest integer. So again, if we are trying to get x by itself and it is squared, we have to do the inverse operation of squaring something, which is square rooting. So my task here, my step, is to square root on both sides. And again, as soon as you're solving for x and you're taking the square root on both sides, this is where you are going to get those two answers, those two square roots. So please don't forget to put that plus minus sign. Hint is also why they're telling you to select all, because as you guys can see in our answers, we have positive answers and we have negative answers. So that is another sign to remember your plus minus sign, okay? So if I were to take the square root of 63, they're telling me to round it to the nearest integer. So this 7.9 will be rounded up to 8. So my answer is going to be plus or minus 8. So that means it's a positive 8, which is D, and it's also a negative 8, which is A. So you're using the same logic when you're answering 22, 23, and 24. All that you're doing is you're taking the square root on both sides to get x by itself. And yes, you must show that step. So then when you take the square root of 81, please don't forget the plus minus sign. If you guys forget that, it is -1 on your test, okay? So the square root of 20 or 81 is plus or minus, and then it would be 9. Same thing, 23, to get rid of a square, the opposite of squaring something is square rooting. So when you take the square root of 243, you get plus or minus 15.58, and it tells us to round it to the nearest tenth. So to the nearest tenth, my 8 is 5 or greater, so I'm going to round the 5 up to a 6. So this answer is plus or minus 15.6. And then the last one, solve the following equation, round to the nearest integer. So again, to get rid of a squared, I'm taking the square root. And my answer is going to be x equals plus or minus, and then the square root of 80 is 8.9. And again, when they tell us to round to the nearest integer, looking here at the 9, it's 5 or greater, so I'm going to round the 8 up to a 9. And that is it. Okay, so please let your teacher know if you guys have any questions over this, and I hope you guys have a great rest of your day.